One of the mistakes that students make when dealing with trigonometry is they forget that the triangles move around. So if this is 7.5 and that is 11, and that makes that triangle, then that triangle can shift to there and get 7.5 and 11 again, right? Now once I move that there, what angle is this? 90. So the only part I need is this in here, correct? How long is this? 7.5. How long is this? 11. And I need that angle, don't I? So my theta is what I don't know. What is 7.5 with that theta? Is it adjacent or opposite? It is adjacent. So my adjacent is 7.5, and my opposite is 11. Shift tan of x equals 7.5 over 11. And when you punch that into your calculator, you get an answer. And that answer is 34 degrees. Yeah? But that is only, and this sometimes helps to zoom in even more. That is the 34. That is 90. I need to cut all of it. So what number is that? 124. Because it was 34 and 90. Everybody cool? And I know it doesn't seem like you'll ever use trig in real life or anything else for that matter. But 2 weekends ago, I was indeed putting baseboards into my mother-in-law's condo, and we had to do trig. So it does have its uses. And the last question, a lot of people have problems with this question too, because it doesn't give you any numbers, does it? But you all know what a ladder leaning against a wall looks like, right? How do I draw the wall? Floor, wall. Agreed? Okay. And where does the ladder go? Up against the wall. There's the ladder, yes? So I'll make it look a little bit like a ladder. There we go. Now, safety reasons, a ladder is to be distance between the base and the wall is no greater than 1/4 the length of the ladder. Do I know the length of the ladder? No. But I know that this distance can't be bigger than 1/4 of that length. Does it matter what the length of the ladder is? No. Whatever ladder I lean against the wall, this has to be 1/4 of this. So what am I allowed to put here? I can put any number I want, can't I? And this has to be what? 1/4 of that. So what would be a smart number to put here? Any number that does what? Divides by 4. Okay, if that's 8, what's this allowed to be? 2. Then I want the angle of inclination, yes? Where is the angle of inclination? Is it ever the 90? No. Is it the green dot or is it the red dot? It is the red dot. So theta equals x, because that's what I don't know. Adjacent equals 2, but I'm in trouble, aren't I? because I only know what to do if I have a hypotenuse. Hypotenuse doesn't help me, does it? We don't know how to deal with that yet. So I'd better find my O first. How do I find this value when I have these two? Pythagoras. This is the square root of 8 squared plus or minus 2 squared, which is the square root of 60. Right? 64 minus 4. So the opposite is the square root of 60. How do you find the square root of 60? You use your calculator. It's going to be about 7.8, right? Right? So whatever your calculator gives it to you as. So let's call it, what is it really? Someone must have punched it in by now. 7.74, okay, 7.74. So now I know my A and my O, don't I? So shift tan of x is O over A, 7.74 over 2. And then I do shift tan, and I get my angle. And that answer is down at the bottom there somewhere. Yeah? Right. Yep. Yep. Because I have a hypotenuse. A squared plus b squared equals c squared. So if I have c squared, I must be doing subtraction. Now, of course, some of you forget that. And if you forget that, you would go 8 squared plus 2 squared, which would be 68, right? And then when you take that square root, that is like 8.2. And some of you will actually write 8.2 there. Why is that silly? How can that be longer than my hypotenuse? Right? All of you are guilty. I shouldn't say that. Generalizations are horrible. Most of you are guilty about grabbing your calculator and punching numbers in before you think about what you're doing. And then you hit equals, your calculator gives you an answer, and you write it down before you think about it making sense. Okay? Okay. You know, Malik, hiding your phone behind your water bottle doesn't actually work. Okay. Just making sure. I wouldn't want you to think that you were smarter than me. Okay. Jenna.
So on the answer thing it says 136 degrees for 19 and you got one.
Oh, does it? Well, let's see what we did wrong then. So we had this. We had 7.5. We had 11. We had to shift. Oh, duh! I put adjacent over opposite. What an idiot. What's tan? It's opposite over adjacent. What a maroon. 11 over 7.5. What an idiot. Why you guys wait that long to tell me I was an idiot? Most of the time you're jumping at the chance to tell me I'm an idiot. And today you decided not to? What a moron. So that's going to be whatever it is. And then, but the rest of the math stays the same. Now, let's turn this into a teachable moment. What if you, on a test, moved the triangle over, recognized that was 90, found this angle, and added them together? You did exactly what I did, and the question was out of 4. What should I give you? 3 out of 4? That seem fair?
Yeah.
I agree. Pretty simple, right? The lowest I would ever go would be 2.5. But I wouldn't give you 50 because you did 99% of it right. The only time I would screw you over that way is on this type of question. Like if you do Pythagoras wrong and give me an answer that makes no sense, can you argue that you are meeting my expectations when you give me an answer that makes no sense? No. But here, the difference was we said it was 124. I said it was 124, and it's really 146, right? The difference of that is usually keep a protractor handy. This is about 20 degrees. Using your eyes, you can't tell if you've got the answer right or not, right? Because 124 is about there. That's probably 146, and 124 would be about there. You understand? So you can't really tell if you did it wrong. Everybody cool? But if the answer makes no sense, that's a totally different kettle of fish, to quote an old saying. Everyone's cool with that? So I'm glad I was an idiot for that question, because it allows me to say what I would do if you made that same error. Okay? Sweet. Heather.
What's the actual answer?
146. Whew. How embarrassing. All right. If we could all go to page, I don't know what page it is, page 58. That would be really, really good. $58. Nathan.
What if the decimal you did wrong almost speed, not the shift? Like, what is it representing as a triangle? Question.
Give me an example, because your question is confuzzling to me.
Question 6 on page 55. Like, the missing value. Oh, no, that's not it. Never mind. What's the difference between doing the normal tangent or doing the shift tangent?
Shift tan finds you an angle. Normal tangent finds you a side. Okay. So we are back at 58. Now, tangent is not the only trig ratio. So everybody up here, please draw us a triangle. Draw yourself a triangle. Make it a right angle. Label it A, B, C. And give yourself a theta. All the trig we have done so far uses a theta, and we can use opposite and adjacent, right? That's what we've done so far. That's tangent. Now, what if I'm up here at this theta? The numbers change, but the concept doesn't. Yes? I use opposite and adjacent. Everyone's cool, right? But tangent doesn't help us find Pythagoras, find the hypotenuse. If I do tangent, I get these two legs, then I could do Pythagoras to find the hypotenuse, yes? But that seems cumbersome. It's an extra step. And it is indeed an extra step, because there are two other buttons on your calculator beside tan. Sine, which on your calculator is sin, naughty. And cosine, which on your calculator is cos. And those deal with the hypotenuse. Okay? The sine ratio compares the opposite measurement, which we already know how to do, with the hypotenuse measurement. And the cosine, you're smart kids. If tangent uses opposite and adjacent, sine uses opposite and hypotenuse, what must cos use? Hypotenuse and adjacent. And once you have all three of them, that makes this stupid little fake word that isn't a real word, but we use it in trig all the time. And you say it SOHCAHTOA. Sine deals with opposite and hypotenuse. Cosine deals with adjacent and hypotenuse. And tangent, which is our good friend because that's what we started with, deals with opposite and adjacent, right? Now, of course, we know that tangent is O over A. So what then is cos? A over H. And what then is sine? O over H. Everybody cool? All right. Now, if you would be so kind as to draw us, yourself, another triangle, and label it again A, B, C. You know what? No, just leave it as ABC. That's cool. There's the 90, right? Now, how many angles on here right now would we use if we were going to do some trig? Which two? Right. So we don't do any trig on 90 degrees. We use trig for A and B, right? So that must mean that there is a sine of A cos of A, and a tan of A, correct? If I'm dealing with A, where would I be sitting if I were in the triangle? I'd be right up at the top. And there I am. Right? Which means, what is this side here? Opposite. And what are its three names? CB, BC, and Lil A. What is this side here? AC, CA, and Lil B. And what's this side here? AB, BA, and Lil C. Okay? So, what is the sine of A? Well, sine of A is O over H. What is the opposite? Lil A over Lil C. What is the cos of A, which is A over H? Lil B, Lil C, and the tan of A, which is O over A, Lil A over Lil B. Easy peasy lemon squeezy, yeah? Great. Now do the same thing, but now we're going to work with B, B, and B. So what do you get? So the first one becomes O over H. I'm not going to write that again because we've written it 3 times, so just give me the letters. No. I am no longer at A. I'm down there now. So it's Lil B over sine O over H. Lil C. What's cos? Cos is adjacent over H. No. Little a. A over C, because hypotenuse never changes. That's supposed to be red. Fine. Oh, screw you. You guys finish that off while I yell at my machine. Lil A over Lil C, and tan, Lil B over little a. And what do you notice? The sines and the cosines work together. The sine of one is the cosine of the other. The cosine of one is the sine of the other. The tangents are reciprocals. Why? Because we change our point of view. The only side that doesn't change is what? Little c, or if we're not labeling in little c, a and b, the hypotenuse. Never changes. Nathan. Well, this could also be CB over AB. I'm not, okay? All right. Is everybody cool? Okay. Let's apply that on these three questions. We've done a bunch of trig questions, and we had a method, didn't we? We wrote theta, O, and A, right? Did that method work for the previous bunch of questions? It did. So we're going to do the same thing here. Do I have a theta? What is it? 12, which means there is where I'm sitting. Once I have established that I am there, what is that? Opposite, and that's x. What is that? That's the hypotenuse, which is 25. What uses O and H? Sine. So I write sine theta is O over H. Then I write in what I know. Sine 12 equals x over 25. And how do I get rid of that 25? 25 sine 12 equals x. Now, what is the only difference between all the work we've already done and now? We're going to push a different button. But everything else is the same. And the button that we are going to push is sin. Now, does our calculator still need to be in degrees? Yes. Do I need to make sure I am multiplying or dividing appropriately? Yes, that's why I write it out. If I have a backwards calculator, whose responsibility is it to know how it works? Yours. So, without yelling out the answer, everybody get the answer. I'm going to write the answer down in about 2 seconds, and I'm going to hope that I hear 30 kids go, yes. I won't hear 30 kids because some of you aren't doing it, but that's okay. The answer is 5.2. Yes. Nathan.
I see on all of these, like, the sin, they all have, like, the shift.
Uh-huh. Works exactly the same way as tan. All right, let's look at the next one. Do I have a theta? What is it? 19, which means I am now right there. So what does that make this? Adjacent is 40. What does that make this? Hypotenuse is x. What uses A and H? Cos theta equals A over H. Cos of what? 19 equals what? 40 over what? How do I tidy that up when the denominator is the variable? Division. X equals 40 over cos 19. And again, I will wait a second for you to try and get the answer. Does anything change? We hit the cos button, but nothing else changes. I will wait a moment for you to get that. And the answer is 42.3. Yes. No different, is it? You just have to know what you're pushing. Now, do you even have to memorize SOHCAHTOA? No, because if you look on your data sheet, there's a whole little corner of it that has trigonometry on it. Look at that! I know, right? I'll try to make it easier for you. Oh, wait, I can't. Okay? Okay. Let's do the third one. I feel like this color blue. Do I have a theta? I do, but it's x. So that means I am right there. So what does that make that 13? Adjacent is 13. What does that make that 22? Hypotenuse is 22. What uses A and H? Cos of x equals 13 over 22. Since I need the angle, good luck, is it shift cos or regular cos? Shift cos. 13 over 22. So x equals, and I will wait a moment. Everybody ready? It's 54. Yes. Because, of course, in a degrees, you round to the nearest degree. Is everybody good? Great. Take your 2-minute break that you do not get to leave the room for. Talk to your neighbors now. Send your texts now.
So I can't get one.
Nope. What? The next page? That's going to be what you work on today. But notice there are 2 pages of it. I'm going to be shutting up in a minute, but not quite. Yes. So, if you have a backwards calculator, you cannot do this the way you see it. You cannot do shift cos 13 divided by 22. You reverse it. So you go 13 divided by 22. Then you need to either hit equals or you need to have used your brackets, whichever you're more comfortable with. Which are you going to use? Equals, so you will go 13 divided by 22 equals, and that will give you a number. Then you will go second cos, and you will get 53.77. Yep. Yep. Is what you use to find the side. Yep. The problem with, I don't like saying it, what you just said, because then you guys think that cosine is some measurement of the triangle. It's not. Cosine is the ratio of the 2 sides. It doesn't give you any measurements on the triangle. Time is up. Back to business. Now, ladies and gentlemen, please be aware that it is impossible to do this wrong if you write it out. If you can find theta and you know what opposite and adjacent and hypotenuse means, you really can't do this wrong. The only way you can do it wrong is if you're a little poopy with your calculator. But if you show me all of this, does that show me you know how to do trig? Yes. Is this unit a unit on trigonometry or is it a unit on calculator? It's a unit on trigonometry. We will do so much practice, you will learn how to use your calculator. But the reason I want you writing it all out is because you guys get sometimes very discouraged when you can't get the answer, even though you've written it out right. and you equate being bad with your calculator with being bad at math. And that's a big error, okay? Flip it around the other way. Let's say you go 82-0 when you play NHL 2K19. Does that mean you're ready to strap on the skates and go play with the Canucks?
Yeah.
No, it doesn't. I got 87 headshots in Call of Duty 97. Are you ready to go to war? No, you're not. No matter what you think. Yes, you're ready to go be a hostage negotiator. Go for it. Okay. Everybody cool? All right, now please notice I am doing very small increments here, yes? The first day, we just talked about what made tan. Then we applied it. Now we're just talking about sine and cos. Now we're going to apply it. Look on page 59. Again, you see the answers are there. Please notice that 59 always provides you with the triangle or exactly what I like you to do. When you get to 60, you will see it starts providing you with the triangle, and then it starts applying the triangles to real life. Now, this is a little bit hard to see on my page. I don't know how well it printed on yours, so I'm just going to go ahead and draw this triangle on page 60. If you can see it, you don't need to pay attention. This angle is 58.5 degrees. And I know I said we don't use decimals for angles, but I want you to see different numbers and recognize that no matter what it looks like, we do the same thing. And this is, of course, you should be able to read it, is 25.23. Is everybody cool? No, there is nothing between C and D. That is the angle. That's why I got the little degree sign there. Okay. Now, page 59 and 60 are almost exclusively cosine and sine. Tan might come into play, but it shouldn't. Everybody cool? All right. And I am giving you now, it is 12:13. You have until, I would like to be talking about this and making sure you are in good shape at around 12:35. Okay? Sine, cosine, and tangent are ratios. You are taking a measurement on the triangle, opposite, and you are dividing that by the hypotenuse. This would be some number of centimeters or meters or millimeters or miles or whatever. This would be some number of centimeters. This, that decimal, is nothing. It is just that comparison. Okay? It is not in centimeters. It is not in degrees. It is nothing but that comparison. And the reason we do it is because, oh, look, there's an old drawing of me. 57, the sine of 57 is 0.866, which means that if you ever go any distance this way and divide it by this distance, you will get 0.866, which means if you go 866 meters there, that means you've gone 1,000 meters here. If you go 8,660 meters there, then you would go 10,000 meters there. No, it goes by anything, Nathan. This division will always be 0.866. I am using 866 and 1,000 because 0.866 is 866 thousandths. It is also 432 500ths. It is also 43.250. That's why trig works. The ratio is just there so we can find the actual distance in real life. because no matter how big I make this triangle, and I'm off the screen, this angle doesn't change. The ratio is not anything except a way to find out what the actual measurements are. Everybody cool? All right. So, all the answers are right there. It shouldn't be a problem. What I am willing to do, or what I need to do right now, is to ascertain that all of you understand how you get to those answers. Do you?
No.
Which ones, Jenna? A. So, in 4. Okay. Where is angle A in triangle 1?
Oh no, I'm sorry, 4B.
4B. Okay. So determine sine A. Well, sine A is opposite over hypotenuse. Where's A in triangle 1? Right there, yes? What's opposite of A? Right. What number is it?
6.
So it's 6 over, what's the hypotenuse? 10. 6 divided by 10 is 0.6. That's the answer. Sam?
So for number 6, you have to find what you do instead.
No. Number 6 is asking for the degree. What finds me a degree? What have we done to find a degree in every question when we were looking for a degree? We did shift, sine, or cos, or tan of the decimal. Go for Myers. Hey, I'm what? Yes. I do not mind that at all. Okay. How's here? Mr. Campbell would like to see you. So everyone is cool with this page now? Yes? So go back and take a look at it. Now I can only assume, I'm just going to pick one of these at random. D. So I need the measure of each acute angle. Those are the angles that we care about, less than 90. So I need that measurement and that measurement. Since I'm looking for an angle, what do? Shift. Now, because I only have these two sides, when I'm at Q, what is 2.2? Opposite or adjacent? Adjacent. What is 2.9? Hypotenuse. So I must have to do cos of Q, 2.2 over 2.9. When I'm up here at the P angle, I have, what is 2.2? It is opposite. So I must have to do sine P of 2.2 over 2.9. Is everybody good? Now some of you will say, but Mr. Myers, couldn't I just do Pythagoras and get this third side and then do whatever I want? Yes, you could. But that would require you to take an extra step. And since all of you run out of time, no matter how much time I give you, you should probably start looking for ways to save some time. Because if the class had their way, I would give you from now until June to write your next test. No. Because in the real world, there are deadlines, and you have to be able to meet them. Okay? Any questions on page 60? 59. Okay, now if you didn't get it before, you should get it now. You can go back and look at it. Did anybody do anything on page 60? Yet. Okay, so you're working on page 60. Quiz 1, tomorrow, your first trig quiz. That trig quiz will have sine, cos, and tangent on it. Tomorrow you will work on the puzzle sheets, and with any luck, I will feel that there has been enough work being done tomorrow that I won't need to go on and do another lecture because it's Friday and I'd rather not do that. Satjo. Anything from? Okay. Yes. That is what you're supposed to find here. That distance. And of course, that is the real use of trig, or the use of trig that you people see in your lives on a fairly regular basis. When you see those road workers looking through a telescope at some other guy across the street holding up a flag, they're doing trig. And they're being paid tens of thousands of dollars to do it. And all they're doing is grade 10 trig and playing with a cool telescope. But people think they're magicians. They're not. It's grade 10 trig and you're pretending to be a pirate. Yar. That's okay. Surveyors would say there's a lot more to it than that, but everybody says that about their job. But there is, of course, a lot more to it, right? You don't just get to walk out there. They have to be super exact. There's no, I think it's like about this.